Mysterious clouds on Venus are changing. They may contain microbial life. September 10, 2019. Having the same size as Earth, Venus is a terrestrial planet with a composition similar to our planet and is almost as close to the Sun. But the parallels practically end there. Mysterious clouds on Venus are changing. They may contain microbial life. A composite image of the planet Venus, viewed by the Japanese Akatsuki spacecraft. Credit, Akatsuki, Astronautic Space and Science Institute / Japan Aerospace Exploration Agency. Venus is much warmer, in the vicinity of 460 degrees Celsius at the surface, due to an uncontrolled greenhouse effect caused by a dense, carbon dioxide-rich atmosphere and a cloud blanket made up mostly of sulfuric acid droplets. That planet rotates in the opposite direction of the Earth. The Sun rises in the west, and its surface has never been seen by the human eye because it is completely obscured by its opaque and highly reflective clouds. But, like Earth, the Venusian climate is driven by solar radiation and is profoundly influenced by changes in the reflective properties or albedo of the clouds surrounding the planet. And now a better picture of this climate and how it is influenced by changes in cloud reflectivity has emerged, thanks to an international team of researchers using a set of satellites to evaluate the long-term variations of Venus albedo in ultraviolet light. The new study was published August 26, 2019 in the astronomical journal. Sanjay Limay, a University of Wisconsin-Madison planetary scientist and co-author of the new study, explains the difference between Earth and Venus is that on Earth most of the Sun's energy is absorbed at ground level, while on Venus most of the heat is deposited in the clouds. What is curious about the clouds of Venus, besides being unlike anything on Earth, is that in these clouds there are mysterious dark spots, dubbed absorbers unknown by scientists, because the tiny particles that make up the spots absorb most of them. Ultraviolet rays and some of the visible light from the Sun, and thus affects the planet's albedo and energy budget. The spots were first observed by ground telescopes over a century ago. They shrink and flow over time, changing their distributions and contrasts. Yeon-Ju Lee, senior author of the new report, explains. It has been suggested that the particles that make up the dark spots are ferric chloride, sulfur allotropes, disulfide dioxide, and so on, but none of them have so far been able to satisfactorily explain their formation and absorption properties. On the other hand, Limay notes that the particles are about the same size and have the same light-absorbing properties as the microorganisms found in Earth's atmosphere. Also, scientists, starting with the noted biophysicist Harold Morowitz and astronomer Carl Sagan, have long speculated that the dark spots on the clouds of Venus are, in fact, microscopic life. Whatever their composition, Venus unknown absorbers, according to the planet's new albedo measurements, a feat led by Lee from the Technical University of Berlin, are affecting the planet's climate. Lee and his colleagues, including Limay, have studied changes in Venus albedo using more than a decade of ultraviolet observations of the planet from instruments aboard the Venus Express, Akatsuki and Messenger planetary probes, in addition to the Hubble Space Telescope. Between 2006 and 2017, Venus albedo, the measure of ultraviolet light reflected back into space, have before it began to recover. These changes in the planet's albedo caused large variations in the amount of solar energy absorbed by the clouds and, consequently, in the circulation of Venus's atmosphere. In particular, changes in the albedo help explain variations in the vigorous activity of the planet's upper atmosphere, which exhibits what scientists call superrotation, a phenomenon driven by winds exceeding 320 km per hour. Takeshi Horinouchi of Japan's Hokkaido University, also co-author of the new astronomical journal report and Venusian climate expert, says the new results of changes in the planet's albedo provide a link between solar warming and the strong gusts that sustain the climate dynamics of the upper atmosphere of the planet. Venus expert Mark Bullock of the Southwest Research Institute, who did not participate in the new study, says, "What really struck me about this article is that it shows that Venus's climate has decadal climate variations, just like Earth. Even more surprising, the strength of the climate fluctuation on Venus is far greater than the long-term variations of the Earth." Limay adds, "This is an impressive result. This suggests that something is changing. We can see the change in brightness. If the albedo is changing, something is driving those changes. The question is, what is the cause?" The ebb and flow of the mysterious dark spots on the tops of Venus's clouds, the unknown absorbers, are near the top of the suspect list and could, in fact, be playing an important role in these changes, say Lee and Limay. Fog above the clouds and made up of smaller particles, they add, can make Venus look even brighter. The weather, either on Earth or on Venus, is caused by solar radiation, including ultraviolet radiation that we cannot see. And clouds and their ability to reflect light have a huge influence. Lee asks, is solar ultraviolet light affecting the cloud cover of Venus? Do cosmic rays, subatomic particles of space continually raining on all planets, affect cloud cover by triggering cloud nucleation? Would planetary sulfur dioxide affect the formation of the sulfuric acid cloud? The new study helps to deepen the dynamics of Venus's albedo and the possible effects of the enigmatic dark spots that roam the top of the planet's cloud banks, if not their composition. But the results are likely to pique the interests of scientists studying the planet and its climate, which may give new lessons about the Earth and its climate.